Hi everyone, I'm Abhishek Dharmaratnakar from YouTube, Google. So I'm a staff software engineer and AI researcher at Google. So today I'm here to talk about generative AI for video trailer synthesis. So we'll go all the way from extractive heuristics to autoregressive creativity. So once again, welcome everyone. Okay, let's start. So imagine sitting in a darkened theater, holding your breath as a perfectly timed sequence of images and music flashes across the screen, hooking your emotions completely. This is the magic of phenomenal movie trailer. Today we are exploring a profound paradigm shift in how that specific type of promotional video content is created. We are looking at the rapid evolution of video trailer synthesis, moving far away from traditional extractive heuristics into an entirely new era characterized by autoregressive creativity and deep generative synthesis. This comprehensive paper, authored by me and my friends Anushri Srivats and Bibanshu at Google, breaks down exactly how the industry is transitioning from simply hunting for the best existing frames to actively generating novel audiovisual narratives from scratch. Okay, let's deep dive. To understand why this incredibly complex technology is strictly necessary, we first must look at the immense pressure within our current digital ecosystem. Platforms like ourselves, YouTube, TikTok, and Instagram Reels operate on the brutal logic of content velocity, experiencing extreme platform saturation with over a million hours of video uploaded on a daily basis. If you are a creator or a studio, traditional manual video editing is incredibly labor intensive, taking hours to produce a single promotional shot, which makes it completely non scalable for the sheer volume of data. As the red line on our ecosystem chart clearly demonstrates, the volume of user generated content and streaming media is skyrocketing at an exponential rate, while human editing capacity remains entirely flat. Bridging this massive automation gap is no longer just a technological luxury, it has become an absolute economic imperative for creators and distribution platforms like ourselves to simply survive in a hypersaturated market. Let's look at the paradox. Before we deep dive into deep learning models, we have to establish a foundational philosophy. We must rigorously distinguish trailer generation from much older standard field of video summarization. A video summary is entirely utility driven, functioning almost like a textbook. The primary goal is to minimize redundancy, preserve chronological order, and accurately reveal the plot so that the viewer saves time and understands the whole story. On the other hand, trailer is an adversarial and highly persuasive piece of art. The core goal of a trailer is to actively induce curiosity in the viewer, which ironically requires the editor to purposefully hide the resolution of the story and intentionally present shots completely out of the chronological order to build a suspense. So, how do we represent this like mathematically? Like, okay, early psychological and physiological models proved that effective trailer generation is really about mastering pacing, rhythm, and biological stimulation, not just finding shots with the highest pixel quality. This mathematical chart illustrates a concept known as self correcting point process, which tracks the dynamic ebb and flow of viewer attention. The dramatic upward curve on the graph represents a viewer's accumulating boredom, stimulating simulating how their need for fresh visual stimulation exponentially increases over time if a scene drags on. When the automated model perfectly injects an exciting trail over the shot, it essentially acts as a visual dopamine hit, instantly correcting or dropping that boredom level back to zero so the cycle of engagement can begin around. So, yeah, let's get into the generations of how this was created. First is extractive heuristics. During the first generation of automatic trailer generation, systems were quite rudimentary and relied heavily on rigid rule based filtering heuristics. Think of an era as of this era as a throwing raw footage through a series of blunt mechanical gates, so to see what survives. If the motion intensity in the frame was exceptionally high, or audio decibels were incredibly loud, or if the visual gaze variance met a specific mathematical threshold, the algorithm blindly kept the shot. The fatal flaw in this era was that these systems successfully identified high signal intensity, but they completely lacked any semantic understanding of the actual human story. Just because an explosion is incredibly loud does not automatically mean that it belongs to a nuanced emotional trailer, and these early modes simply could not tell the difference. Let's look at Gen 2, graph topologies and structure. To solve this massive lack of semantic understanding, the second generation of researchers introduced graph convolutional neural networks into the pipeline. So instead of viewing a movie as a boring linear stream of consecutive frames, this advanced approach treats the entire film as a complex topological graph, mapping individual shots to standard screenwriting storytelling beats like Blake Sinder's famous Save the Cat structure, identifying the catalyst or the grand finale. This was the massive breakthrough because it allowed the AI to mathematically link a very quiet, visually simple setup shot directly to a loud, chaotic climax shot, allowing the system to move beyond simple pixel energy and finally understand the structural narrative function of a scene within the broader story. Let's look at the next one, which is what's the gap here. However, even with these structural advancements, with both the first and second generations, eventually hit a hard technological wall that we call extractive ceiling. Because these older systems are strictly discriminative ranking models, they are fundamentally limited because they can only select the pre-existing frames that a camera actually captured. If a human director made a mistake or simply never filmed the perfect connecting shot required to make the trailer's transition smooth, the AI is helpless and cannot fix it. This rigid limitation results in a semantic gap, frequently leading to jarring, disjointed narratives that completely lack the necessary visual connective tissue that makes sense to the human viewer watching that. Let's look at the shift. The systemic failure brings us to the third wave, detail also in the research paper, which represents a massive turning point, the generative shift. We are no longer just sifting through footage. We are officially transitioning from discriminatory ranking models directly into the realm of full generative synthesis. The objective for these modern systems is no longer just rummaging around to find the best existing shots in the digital bin. Instead, these models are actively and mathematically constructing the perfect chronological sequence directly in a latent space, acting more like a digital illusionist, viewing a new reality rather than a traditional editor just cutting tape. Okay, let's look at some approaches. So, the first approach within this generative era involves utilizing LLM, such as GPT-4 or Gemini, to act as overarching creative director of the entire project. In this multi-stage generative pipeline, the LLM acts as the intelligent boss, orchestrating a team of highly specialized AI tools to build the trailer. It handles the high level narrative reasoning and storyline segmentation. It explicitly directs Clip to act as the editor for visual semantic matching and retrieval. It utilizes TTS models to creatively synthesize brand new voice over scripts, acting as the narrator, and it actively prompts audio models like MusicGen to score the piece with appropriate emotional beats. The final output from this orchestrated pipeline is a beautifully merged, fully synthesized multimodal narrative. Let's look at a hybrid co-creation for large industrial applications, especially when dealing with non-fiction documentaries or highly sensitive educational content. We frequently deploy hybrid co-creation model rather than just letting the AI run entirely unchecked. In this specific workflow, AI act as an assistant that rapidly generates a rough draft cut, which a professional human editor then meticulously reviews and refines. The critical step creates a continuous reinforcement learning loop that acts as a vital feedback signal, teaching the AI that what works and what fails. Implementing this human in the loop system is absolutely essential for maintaining strict brand safety and actively preventing devastating PR disasters caused by AI hallucinations in factual real world content. Okay, let's look at approach two, which is end-to-end neural synthesis. This is the second major generative approach seeks to remove those separate, clunky modular steps entirely and instead utilizes an incredibly sleek end-to-end differentiable architecture. The pinnacle of this research is that trailer generation transformer, commonly also referred to as TGT. TGT fundamentally reframes the entire philosophy of trailer creation by treating video editing not as a visual task, but as a complex language translation task. It simultaneously analyzes the visual, auditory, and textual features of the source video all at once, creating a massive cross-model fusion that allows neural network to truly learn the hidden grammar and syntax of cinematic editing. Okay, let's look at what's inside this TGT architecture. If we look around, we look under the hood inside this, like we see several brilliant innovations. Like some of them, first, trailerness encoder. It scans the entire global sequence of the movie and dynamically injects positional attribute encodings, giving the model a bird's eye view of where the most exciting moments live. Next, the context encoder. This uses complex self attention mechanisms to logically connect distant shots together, fundamentally understanding that firing a gun in one scene is directly linked to a character's reaction shot 20 minutes later in the film. Finally, the autoregressive decoder doesn't just rank shots, it mathematically predicts the optimal next visual token based heavily on the previously generated context, proving the model has actually learned true artistic shot composition rather than relying on simple chronological ordering. Now let's look at the third approach, which is arguably the most jaw-dropping advancement in this space, known as foundation frontier, which highly involves text-to-video foundation models like Sora, VO2, MovieGen. These massive latent diffusion models completely shatter the old rules by fully decoupling the trailer creation process from the rigid physical constraints of the original source footage. They offer unbelievably high fidelity physics, flawlessly simulating complex real world phenomena like fluid dynamics, light reflections, and object permeance, all while successfully maintaining long form temporal consistency that was completely impossible just a few years ago. Okay, let's look at how it does. Remember the devastating semantic gap we discussed earlier, which is like basically a missing shot ruins the whole trailer. Those foundation models completely solves this. These foundation models like BO or something, they actually solve this nightmare by a process called abstractive filling. For example, if we have an intense shot of a hero looking up and subsequent shot of a monster attacking, and no connecting shot to build the tension, the AI can completely synthesize a brand new bridge shot, such as generating the hero's terrifying point of view of the monster's looming shadow. Furthermore, they can perform radical style transfers, completely regenerating a sunny daylight scene into a dark, ominous light night scene to perfectly fit the specific tone of a horror trailer. This technology is profoundly blurring the historical line between traditional video editing and high end visual effects. Let's look at some of the taxonomy of this automatic trailer generation. This table serves as a historical map, uh, perfectly summarizing the entire technical evolution we have discussed so far today. We can trace our steps from the early days of heuristic rules, relying on simple audio energy and short boundaries, to effective models meticulously tracking human gaze variance, all the way to graph based systems enforcing rigid short beats or story beats. Today, we have officially abandoned those old methods and operate entirely in the bottom half of this table, which is actively utilizing LLM agents for narrative planning, autoregressive transformers for complex translation and sequencing, and powerful diffusion models for raw pixel generation. Okay, let's look at, is this economically feasible? However, the creative potential of this technology is nothing short of incredible, scaling it to the massive size of a UGC platform, like user generated content platforms like YouTube, is that introduces a terrifying compute bottleneck. Recent economic modeling suggests that the processing is just 1 million hours of video using these heavy multimodal AI encoders requires tens of thousands of GPU hours on a even like the best A100 class hardware racks. To make this technology like economically viable rather than just a massive money pit, the industry is frantically researching and prioritizing advanced optimization techniques, specifically focusing on model distillation, aggressive quantization, and local edge deployment strategies. Okay, so from a purely industry and marketing standpoint, this ultimate goal of automated trailer generation is to mathematically maximize the narrative hook and click through rate for every single individual viewer. By mining massive datasets, AI systems can analyze specific storytelling tropes, like the tension of a jump scare or a romantic setup of a meet cute, to identify the exact visual elements that correlate with high user engagement. This incredible capability allows a studio to take one single source movie and automatically synthesize dozens of highly personalized micro trailers, generating an action heavy cut for thrill seekers, a romance focused cut on for drama fans, and a terrifying horror cut for genre lovers, all deployed simultaneously for the same single source. Now, beyond precision and recall, as we aggressively shift away from simple extraction and embrace these generative models, we are facing a massive evaluation crisis as our old testing metrics have to completely change. Old retrieval metrics like precision and recall fail miserably now because human creativity is inherently subjective and not simply binary. If the AI makes a brilliant, entirely novel editorial choice that happens to differ from human editors' original ground to trailer, the old mathematical metrics unfairly penalize the AI due to the validity of alternatives problem. Consequently, the industry is moving toward entirely new standards, utilizing fetched video distance to measure pixel level visual realism, calculating beat sheet adherence to ensure proper narrative alignment, and deploying AV sync metrics to guarantee that the frantic visual cuts actually match the emotional audio beats. Of course, like introducing these powerful generative capabilities also introduce the severe and very real risk of AI hallucination, which can destroy trust. If an AI model decides to creatively synthesize dramatic dialogue or intense physical events that absolutely never happened in the original film, it dangerously crosses the line from clever promotion directly into blatant deception. Therefore, strict factuality constraints must serve as a hard, unbreakable limit, especially when generating trailers for sensitive non-fiction documentaries or critical healthcare contexts. Furthermore, because these models train heavily on click through engagement data, we must actively monitor them for bias to prevent AI from prioritizing cheap sensationalism or outliers over a fair representation of the actual story content. So, okay, what are the future research directions that we are taking as we look towards the horizon. This paper actually clearly outlines all the several critical directions for future explorations in this space. First and foremost, we desperately need narrative aware transformers that can seamlessly integrate topological story graphs directly into their internal attention mechanisms to ensure logical long term storytelling. We must also figure out how to mathematically standardize subjective creativity, likely by using massive LLMs to act as semantic judges capable of scoring the logical flaw of an edit. And perhaps most crucially for society, we must universally implement cryptographic provenance tracking like C2PA watermarks to definitively identify between original human capture frames and AI synthesis content. So, to bring everything together, the central thesis of our journey today is that video trailer generation has completely matured from a rigid subdiscipline of basic signal processing into an expansive, breathtaking frontier of multimodal generative AI. The future software systems we are building will not just act as a simple, obedient editors that blindly find and slice shots. They are rapidly evolving into full stack, autonomous creative agents capable of fixing pacing holes, brilliantly scoring the music, writing compelling narrative scripts, and hyper personalizing the magic of cinema for every individual viewer on the fly. Thank you for your time and attention today, and I'd be more than happy to take any questions if you have it.